All right, example 6 was the where we left off. Actually, we did example 5 where it could not be factored. I went back on YouTube and looked. I think that's the last thing that we did. So we will pick up from there and continue. For those who came in late, we are taking one test this marking period, and it's going to be next week. All right, most likely it'll be Thursday. We'll do corrections on Friday, and then you're out of here. All right. So it's up to you. I mean, it's up to you if you want to skip or whatever. I mean, but you're going to be counted for the test. If you don't show up for the test, you don't take it, you get a 0. All right? That's how it works. So don't just think, well, I'm just going to blow this off. It's the end of the year. It's the last day of school. I'm not coming in. I know how it works. Just listen to me, please. Just listen to me. Shh. Stop. Doesn't help. Makes it worse. So you can think that if you want. I told you several weeks ago I was going to teach every single day until the last day of class, and that's what I'm doing. All right? So I'm sticking with my word. So what you need to do is you need to show up. You got the rest of the summer to mess around. Okay, there is no reason not to come in. If you only come in for this class, then come in for it, because we're going to be doing stuff every day this week, as you see on the lesson plans. I got stuff every single day, all right? Next week, we may even do something on Monday and maybe Tuesday. We'll review Wednesday, take the test Thursday, corrections Friday, all right? And then that's it. You only got 2 weeks. Suck it up, all right? Man up, woman up, whatever you want to say. Show up, all right? Show up. That's all I'm saying. Of course, I'm talking to the wrong people because you guys are here, but I'm just warning you for, especially for next week. All right, I know what it's like. I've seen 30. This will be my 36th senior class with senioritis. I understand it. Okay, I get it. But here we go. We are factoring. All right, so let's continue with some more factoring. And yeah, so we actually don't have a ton to do today. Just finish this up. Let me just check my lesson plan thing real quick. Yeah, factoring. Yeah, it should be. That should be good. All right, here we go. It says factor the negative of the GCF. Really, they could just say factor it, but they tell you all this stuff. Let me just write it down. So they use U and V, which I hate when they use U and V, because when when you write it out, it could kind of look the same, especially the way I write. And V. All right, so here we go. So we want to factor out the greatest common factor. So what we're going to do is we're going to look at this and find out what the greatest common factor is. So you got a 6 and an 8. What is the largest number that divides evenly into 6 and 8? 2. That's it. Okay, there's nothing bigger than that. 2 is the only one. So what we're going to do, the question says, I'm not going to write it down, but it says factor the negative of the GCF. So do you see a negative right here? So what we're going to do is we're going to factor out a what? A negative 2, so that we get that first one to be positive. All right, so we're going to factor out a negative. Factor out a negative 2. So we're taking a negative out of both of them. When I say take it out of, we're dividing it by it. Okay, so we're dividing everything by negative 2. Yes? It's the greatest common factor. It's the largest number that divides evenly into everything. All right? So negative 2 divides into that, divides into that. What about the u's? I got a u squared and a u cubed. What's in common with both of them? What's the largest thing that's in common with both of them? Nobody? Well, just the u's. Just talking about the u's. The u squared, right. Because u cubed is not in common with both of them. There's not a u cubed here, but there is a u squared in both of them. There's a u squared here and there's a u squared here, so we factor out that. So that's a u squared. That's a 2. This is v cubed and v squared. What's in common with both of those? No, v squared. V squared's in common with both of them. There's a 1 in common with everything. Okay, so when I say what's in common with that, really, 1's in common with everything, because everything can be multiplied by 1. So that's our greatest common factor. What we're going to do is we're going to factor it out. Okay, factor out. What does that mean? That means we're going to divide it out. When I factor it out, I'm taking this and I'm dividing it by this. Now, I'm going to do this for the first problem. You shouldn't have to do this every single time, but I'm going to for this one just because it's been a while since we've done this, so let's do it. So I'm going to take that 6u squared v cubed. Now, again, you should be able to do this in your head, all right? I would expect you to be able to, but since we haven't done it in a while, I'm going to show you what you should be thinking in your head. You're going to take that first thing, you're going to divide it by your greatest common factor. So divide it by this. So if I divide it by that, I get divided by a negative 2u squared v squared. And so what is this? Well, first of all, negative divided by negative is positive. 6 divided by 2 is 3. U squared divided by u squared, it's just a 1, right? Divides out to be a 1 or cancels out, but I like to look at it as it divides out to be a 1. Then you got v cubed divided by v squared. What is that? It's just v. But you could have done that over here in your head. You could have said negative 6 divided by negative 2 is what? 3. U squared divided by u squared, it's a 1, right? Cancels out. V cubed divided by v squared is v. So you should be able to do that part in your head, but if you need this, it's there for you, okay? You can always write it off to the side, but you should be able to do this in your head. Let's do the rest. Now we're taking the second one. Again, this is the only time I'm going to do this little thing off to the side. We're going to take that second term divided by the greatest common factor. So what are we dividing it by? Negative 2u squared v squared. All right, let's see what we get. Now, here's the key. This is the part where a lot of people would go wrong on this problem right here. It's positive 8 divided by negative 2. What's that? It's negative 4. So 8 divided by negative 2 is negative 4. That right there is enough to get the problem wrong. And that's where a lot of students get this problem wrong, right there. Okay, I've seen it many, many, many times. I probably did it myself. All right, I probably still do it myself if I go too fast with this. So you got to be careful with that. And now, so right there, that's negative 4. What's this? U cubed divided by u squared is just u. And then v squared divided by v squared cancels out. It's times 1. So what do we have here? Minus 4 what? Minus 4u. That's it. That's how you factor it. Okay, even if you're factoring out a negative. Okay, that's what we have. Why do we have a negative here? We had a plus here. Because if you distributed, right, watch, if you distributed, it'd be negative 2 times 3, which is what? Negative 6. But then here's what you need to watch. Negative 2 times what? Negative 4 is positive 8. What if you would have mistakenly not put the negative there? What if you would have put a plus there? You can always check it and go back to see if it was right. So negative 2 times 4 is negative 8, but that's not a negative 8, so I did something wrong. What did I do wrong? I don't want it a plus, I wanted a minus because negative times negative is a positive. All right, enough of that. Now the next one, a little weird, but it still follows the same exact rules as what we did before. But now we're going to have some crazy looking exponents. Sorry. Text from my son and my wife of my picture of my grandson, and he's all dressed up in crazy clothes. All right, had to look at that. So, example 7. Here we go. Again, it's factor. Write this down. This one looks really weird, but we're going to take it step by step, and you're going to see that the steps that we followed in the other problems are the same exact type of steps that we're following here. All right. Well, actually, they kind of start off. This is a little different. They give you the greatest common factor. They're saying take this out of something else. So they're actually telling you what the greatest common factor is. They don't normally do that, but in this one they do. All right. So it says factor this from this thing right here. All right. So they're actually giving you what the greatest common factor would have been. So I told you it looks a little weird. Oops, I'm sorry, not a 2. That's an x to the 2n. Okay? So pretend this was our greatest common factor. Okay? We want to take it out of this. We want to factor this from this. So what did I say was the math that we did? I showed it over here off to the side. It's division, isn't it? Right? I'm taking that greatest common factor and I'm dividing it by this. That's basically what they're doing. They told you the greatest common factor on this example 7, and then you're just dividing it out of this and out of this. So if you go off to the side like we did on this one, you could do the same thing. I said earlier I wasn't going to do that anymore, but I think on this one I think it's necessary. So what we're going to do is take x to the 4n, and what are we going to do with that? We're factoring this from this. So what did we say? We divide. That's right. So I'm going to take that x to the 4n, and I'm going to divide it by what? X to the what? To the 2n. That's right. So I'm going to do that to all three of these. I'm taking this, dividing it by x to the 2n. I'm taking this, dividing everything by x to the 2n. Everybody understand what we're doing? Okay, I'm just factoring it out, dividing it out. So what is the rule? This looks kind of weird, but the rule still works with this. When you have the same bases, you keep the base the same, and what do I do with the exponents? What if I had this? What if I had x to the 5th divided by x squared? Would you divide 5 divided by, would you go 5 divided by 2? What would you do? You subtract, right. So you subtract. 5 minus 2 is what? 3. So what do you do with these? You subtract. What's 4n minus 2n? It's 2n. Everybody see that? It's a little weirder. I get it, because you got those crazy exponents with a variable and stuff in the exponent, but the rule is exactly the same. All right? So the first part of this answer, well, there's my x to the 2n. Right? That's my greatest common factor. What's left? If I take this divided by this, what am I left with? X to the what? 2n. Okay, plus. There's no negatives here, so everything's just plus. So now I do the same thing here. Maybe we don't have to do this off to the side every single time now, do we? X to the 3n divided by x to the 2n. So keep the base the same. What do I do with the exponents? Subtract. 3n minus 2n is 1n, or just n. It's not x times n. I kind of looks a little too big right there. It's x to the n power. All right, let's do this one. X to the 2n divided by x to the 2n. Okay, x to the power of 0, which is a 1. Anything to the 0 power is a 1. Or you could look at it like this. Anything divided by what? Itself. What's anything divided by itself? It's a 1, isn't it? Everybody see that? So sometimes that could be tricky, but really it was kind of easy. Anything divided by itself is 1. Do they just cancel out and just vanish into thin air and go away? No. It's a what? It's a 1. So what do I need to put here? I need to put a 1. Okay? It's not 1x. It's not 1 to the 2n. It's just the number 1. And that's what they want you to do on this one. All right? So they made it a little bit easy for you. They actually allowed you, or they told you what the greatest common factor was. So I stuck it out here, and I find out what's left inside. If you wanted to, you don't have to, but if you wanted to, you could take this and you could FOIL it, couldn't you? Not FOIL it, distribute it. Okay, because there's 3 things here, right? You could distribute it. X to the 2n times x to the 2n. Keep the x the same. What do you do the base, or what do you do with the exponents? Add them up. What's 2n plus 2n? 4n. What do you do here? X to the 2n times x to the n. Keep the base the same. What do you do with the exponents? Add them. 2n plus n is 3n. Plus, x to the 2n times 1 is just what? X to the 2n. Does that look like what we started with? Yeah, and it should. So you can always check to see if you did it right. But I've had students before, and I think when I was in school, when I was doing this stuff, I remember thinking, well, what if you check wrong? What if you do your math wrong when you check it? Well, that's a possibility. You could, all right? But that always happens with checking your work. All right, let's do two more. One more that's kind of like this. So example 8 is kind of like it, except they throw in a negative exponent. And what do we usually do with negative exponents? Well, we usually change them into what? Positive exponents, but we're not necessarily going to do that in this one. So example 8. So it says to factor, again, with these, they're nice to you. They tell you the greatest common factor. They tell you the GCF. So they're saying factor this thing out of or from, the word they use, from this. So it's a to the negative second b minus a to the third b to the negative second. All right, there you go. It's the same style of problem. A little different, a little bit of a twist to it, but it's the same style of problem. So when I factor this out of something, what am I doing? I'm taking this and doing what to it? Dividing it. Very good. Dividing it by this thing right here. So if you need to, go off to the side or just put it right here in the problem itself. Let's do it right now because this could be a little bit tricky, all right, if you try to do this in your head. So I would write this down for sure. So take that first one, a to the negative second b, and what am I doing? I'm factoring this from this. So I'm dividing it by this thing right here, a to the negative second, b to the negative second. Everybody with me? And then put the minus, because you got a minus here. Now you're going to take this a cubed b to the negative second, a cubed b to the negative, oops, forgot the negative second, and divide it by this thing that they tell you is the greatest common factor, a to the negative second, b to the negative second. And now we just have to clean this up. All right, we don't want to leave it like this. If you leave it like this, I'm marking it wrong. You got to simplify it. Now, you do not have to put everything into positive exponents. All right, you can keep everything in the numerator, keep everything on one line. But let's just try to figure this out. What is this? How do I figure that out? Well, the a's actually work out pretty easy. Look at it. I got a to the negative second over a to the negative second. So in your head, what's that right away? Remember, here, listen to this. It's 1. Why is it 1, Azir? Tell me. No. Come on, just tell me. Because it's the same, okay? Anything divided by what? What did I say earlier? Anything divided by itself is equal to 1. That's right. So look, I don't have to do any addition or subtraction on this, do I? All right? Because anything divided by itself is 1. But let's do the subtraction just to show you that it does work out that way. Yes, you did. All right, so what's the rule for division? What do you do with the exponents when you're dividing and you got exponents? If you got the same base, you keep the base the same, and what do you do with the exponents? You subtract when you're dividing. When you multiply with exponents, you add the exponents. When you divide, you subtract. So what is, I'm not even going to put that a right there. So what are you subtracting? You're taking negative 2. You're subtracting what from it? A negative 2. See? Negative 2 minus negative 2. So look what happens. What's minus a negative? Plus. What's negative 2 plus 2? 0. So this is technically a to the 0. But what's anything to the 0 power? It's 1. Now you could go through that nonsense, couldn't you? All right? But isn't it a lot easier just to look at this and say, oh, that's exactly the same as that, so they just cancel out. Yes? Megan, seriously? At least hide it under the desk like you're trying to... No, don't do it. I'm just saying, for goodness sakes. Just so blatant. Put it away. Don't want to see it. Get it out of your lap. Put it in your book bag. Oh, my word. All right, let's look at this. Now, let's figure out what this is. You got the same base. What do you do with the exponents? Subtract. What's 1 minus 2? Negative 1. So that's that right there. I think it is. Yes, I was going to say, I was looking at my notes. I'm like, that is not what I have as an answer. Why is that? Thanks, Alex. I just wrote this down wrong. This should be what? B to the negative second. My bad on that one. So by the way, what's our greatest common factor? It's this, isn't it? And then what's left? Well, whatever this is. So it's b to the what? Yeah, it's 1 minus negative 2. If you need to, do it off to the side. What's 1 minus negative 2? That's a positive 3. See, minus a negative is plus. So that's b to the third. So that's what that is. What about this one? Put a minus. Let's do the a's. So I got a to the It's 3 minus negative 2. Again, if you need to do it off to the side, do it off to the side. 3 minus negative 2 is 5, so it's a to the 5th. What about the b's right here? Come on, we made a big deal about it earlier. Yeah, or they just the same thing over itself, right? Which is also a 1. You can look at it either way. All right. Everybody good? That's your answer right there. That's how they want you to leave it. Okay, they don't care about the negative exponents. You don't have to change it to a positive exponent. They're fine with your answer looking just like that. 0. If B, which one? Which B? This one? This one? This one? Like if one was positive, one was negative, then they're not exactly the same. So you got to do the subtraction. Okay? So if this was like B to the positive second over B to the negative second, you cannot cancel them out. It's a good question. All right? You cannot cancel those out because they're not exactly the same. Got it? So what do? You subtract. What's 2 minus what? Negative 2. What would that be? That would be B to the 4th. But that's not what we have here. If this was like this, if that was positive, let me just get rid of that. So this would be negative 2 minus 2, which would be negative 4. So if it was like this, it would be B to the negative 4th. You got it? It's a good question because they kind of look the same, right? Except one's negative, one's positive. That's enough to make them different, all right? So they're not exactly the same. You can only cancel them out if everything is exactly the same, and they are in those situations. So that would be your answer for example 8. All right, I'm going to show you one more. And I'm going to sign the homework, but I think what I'm going to do is I'm going to start teaching the next one as well. All right, because we're going to have too much time left over, and I don't think you can work on your own. So you've shown me before you can't work on your own. So I will just teach to the end. All right. Right, you just got to put up with me being annoyed at you, but I'll still let you go. I don't ever tell somebody they can't go. Fill out a pass. You just have to put up with me being annoyed. If you can deal with that, then go to the bathroom. Because I'm annoyed most of the time anyway. So, all right, look at this crazy one. This is actually kind of easy, but it looks a little weird because we're not quite used to this. Our greatest common factor here. Our greatest common factor is going to be more than one term. Okay, so that's a little bit different than what we've been used to. Minus b x minus y plus z plus 3 x minus y plus z. Now it looks crazy. It looks weird. Probably doesn't look as weird as the those exponent ones. But at first glance, when you first look at it, you're like, man, I have no idea. What are you supposed to do with this? Well, let's find a greatest common factor. Let's see if there's anything in common with all 3 terms. Do you see the 3 terms? What are the terms separated by? What are they separated by? The subtraction and the addition. Very good. All right, so look. So that right there is one term. That's another term. This is another term. Everybody with me? So now, what's in common with them? Go ahead, Megan. Now you can say it. Greatest common factor. X, Y, and Z. X, say it right. X minus Y plus Z. Very good. That's in common with all 3 of them. Do you see it? You got an X minus Y plus Z in parentheses here. You got one here. You got one here. So now, that's our greatest common factor. So now I got to figure out what's left. After I divide, after I take this and divide it by this, what's left over? This divided by this. Yeah, you just have an A left over, right? Yeah, that's all I'm doing. I'm just writing down the answer. This is all the work. There's really no work, really, to show for this, okay? So minus what? Minus B, keep going, plus 3. That's it. That's your answer right there. It's kind of weird. It is too easy, isn't it? But you know they're going to put a little twist to it, right? It's not always going to be that easy. Add a little pizzazz to it. Right? That's it. That's the answer. I'm not kidding you. I would not kid you about something as serious as this. All right. Everybody good? All right. Let's see what else I got. Took all the stuff out of my notebook. Let me put it back where it belongs. Okay. By the way, for those who walked in late, you may not have heard this, but on the lesson plan, I put number 11 to 69 odds. I changed it to your benefit. It's every third. All right, so you don't have to do near as many. All right, so it's, yeah, I know I am. So section 5.4, it's section 5.4, and I think that's the first thing from section 5.4 I've given you. So we'll call it 5.4a, all right? So section 5.4a. So that's your homework. Now, what I'm going to do right now is I'm going to start on the next lesson. Should I make a new video for this or just add to this? Let's stop this video and I'll make a new one.